So first of all, thank you, Manolo, for the introduction, and I just want to briefly say that I'm really super excited about this project. I was already before, but after hearing all this presentation, I'm even more excited. And yeah, disclaimer: my presentation is going to be quite similar to the one that Paolo delivered, in the sense that it's going to not to be very much technical, and it will be more about the group university. And tomorrow I will present a bit more technical details. Okay, so we are Technical University of Delft. As the name may let you understand, we are in Delft, Netherlands. But where is Delft? Is at the base of the triangle composed of Amsterdam, The Hague, and Rotterdam. And this is a small city, but a very nice historical city, which is the direct expression of the Dutch Golden Age, so with a long cultural history dating much back, much before the beginning of TU Delft. And on the artistic level, just to give some names, on the artistic level, this was the house of Vermeer, and that is indeed a painting of Delft, and not far from where the university is. From Vermeer, and from a scientific point of view, it was, for example, the place where the microscope was invented by a guy that I will not try to pronounce because I'm not Dutch. So this is the campus, as I said, pretty close to the view that you saw before from Vermeer. And so we are in South Holland. TU Delft is one of the 4 technical universities of the Netherlands, and it's actually the oldest and the largest. And it was founded in 1842 as a place where civil servants of the Dutch East Indies were training, and then passed through several changes of name until 1986, when it officially became Delft University of Technology. So despite the relatively short history, we have quite a bunch of nice and notable alumni and faculties, some Nobel laureates in mathematics and physics, and some artists. And here it may be quite relevant, for example, for this project, Theo Jansen, who is probably known by many of you for his kinetic sculpture. So these passive walkers that only use wind to locomote, and you can sometimes see them on the seaside of The Hague, close to Delft. And TU Delft is also part of several research networks. So within TU Delft, we are part of the Mechanical, Maritime and Materials Engineering faculty. And this faculty is composed of 7 departments, so process and energy, precision engineering, material science, maritime and transport, control systems, biomechanical engineering, and last but not least, cognitive robotics. Yeah, since few years, our faculty is considered in the top 10 of the best engineer faculties in mechanical engineering faculties by QS ranking. I thought we had a small flexion. So as I was saying, cognitive robotics, this is where getting closer where we are. So this is a department comprising more than 20 faculties, from assistant up to full professors, and then 2 lecturers, administrative staff, technicians, and quite a lot of PhD students and postdocs. And our main focus is in the interaction between humans and robots in actually a quite broad sense. So we are divided into 4 sections based on the topics. So So we have a robot dynamics section with 4 faculties, and that really goes on the full spectrum on robot application of robot dynamics, is from very theoretical and cognitive to very applicative. This is for example, a picture of the Amazon Robotics Challenge that some of these faculties participated in 2-in-1 a few years ago. Then we have intelligent vehicles section, which is pretty self-explanatory name. And then we have human-robot interaction, which comprises haptic interfaces, proper interaction between cooperation between human and robots, and robotic rehabilitations. And then there is us, which is the section on learning and autonomous control. Our interest is on control, learning, optimization, embedded system, real-time aspects, and we are five faculties. Of these 5 faculties involved in NI, we are myself, and Cosimo della Santina, and Jens Kober. And then we are planning to hire a postdoc. So, by the way, if you have any PhD student which is close to finish that may be interested, just let us know. So, TU Delft is made of 8 faculties. We are the mechanical engineering one, but this is not the only place where people is doing robotics here, and actually 6 out of the 8 faculties have some major involvement in robotics. This is the reason why TU Delft created this robotic institute to coordinate all of our efforts. And this is then ended up in a broader activity which is called Robo Valley, which involves more than close to 200 researchers and a lot of companies. So it's just some nice videos of stuff that is going on here. So, and as said, you can see here some nice videos of stuff that people around the faculty, around the university is doing in robotics. But probably more relevant to our project is the field lab Robo House, which is also part of Robo Valley, so which is a space that has been founded by a bunch of partners, including Robo Valley itself and TU Delft, and is at the same time an incubator for companies and a place where people in academia can go, both in companies and academia can go and build and test prototypes and get in touch also within each other and with companies. So this is would be nice to use this space within our project, for example, for exploitation and dissemination, but also for testing prototype if we get to do some testing here in Delft. And even at a higher level, I will not go more into that, but this is some other activities going on at the level of Delft on robotics. So quite a lot of stuff. So concerning NI, this is the network of work package that we already start to know very well. So, and within this network of work package, our focus as TU Delft would be mostly in work package 3. I would say almost exclusively in work package 3, which is about planning and control. So one of the 3 parts of the mind of our robots, but we have also some minor involvement in work package 1, 6, 7, and 8 for the extent that concern actually control and planning. So more specifically, we are interested in and we will contribute in developing what we could call the low-level circuitry of the intelligence of our robots. So the planning and low-level control. This will be mostly focused, but not only focused on the integrator 3, which is the new articulated soft robot. This is because the animal, of course, already have in place, as we saw before by the presentation by Marco, quite nice planning and control algorithm already working quite well. But also because our really main interest is to not just to provide some nice interface to high level of the autonomy stacks, but also to try to understand how planning and low-level control algorithm can be devised in such a way that the natural dynamics of the robot, so the physical intelligence of the robot, can be really exploited and not cancelled out by control. And how our previous experience of our groups can contribute with that. So as I said, we are mainly two faculties in working on this project. Myself, so I am assistant professor, and my group activities is mostly focused on all the brain related or the intelligence related aspects of both continuum articulated soft robotics, so from learning to model-based control, perception, and also physical intelligence. I thought we will not have explicitly tasks related to physical intelligence in this project, and also a bunch of other activities, some of them possibly connected to knee, like theory of nonlinear oscillation, for example, or control of rigid robots. The other faculty is Jens Colbert, that is an associate professor, and his interest is in all that concern machine learning applied to movements of robot arms, and we can see here two videos of two of his main interests within this big field, which are imitation learning on the left and reinforcement learning on the right. And its common big question across all these aspects are into how to make this algorithm efficient and intuitive by relying either human inputs or prior knowledge on the systems, and with a vast range of applications that you can see here. So these are just some ongoing projects that can be related somehow to NEEM, like, for example, this Open Deep Robotics, which is about developing open source framework for deep learning and robotics. I4 Lab, which is about developing AI helping retails in Netherlands with AI. Then we have the ERC of Jens, which is called Teaching Robot Interactively. So again, pretty self-explanatory name. And then also connected to learning physical human-robot cooperation, we have this project funded by Human Research Institute. And then we have FlexCraft, which is about learning interaction tasks in the context of agri-food industry. And that's all. Thank you very much for your attention.